Hello, and thanks for joining us. In this video, we're going to go over the PCB reverse engineering services that ScanCAD offers. First off, a quick introduction. We are a 30-year-old software company rooted in the electronics industry. Originally, we started in the inspection and measurement environment, as well as programming component locations for pick-and-place machines. But today our software has become a versatile tool capable of everything from complete PCB reverse engineering to automated inspection options. Since the company was founded in 1990, we have continued to grow our global sales and support network. We currently have our systems installed at over 1,000 companies across 50 countries. Along with our growth, we transitioned from simply creating software to offering reverse engineering as a service. Well, what is PCB reverse engineering? PCB reverse engineering, or PCBRE, is the process of taking a physical circuit board or other artwork or datasheets related to that circuit board and using them to generate the original design data. While we prefer working with a physical circuit board because there are a lot of advantages to doing so, we're still able to generate data that reflects the design of the circuit board from almost any source. This includes X-ray imaging, mylar films, datasheets, microfiche. One customer actually provided us with a pencil rubbing on a piece of paper that reflected the drill holes on a test fixture. All that to say, if you have any 2D data source for your PCB, we can create CAD or vector data for it. Now, a better question might be, why do I need PCBRE services? Have you ever heard the term DMS or DMS-MS? It stands for Diminishing Manufacturing Sources and Material Shortages, and refers to the fact that over time, fewer and fewer replacement parts will be available for use in legacy electronics applications and systems. Oftentimes, when a system is installed or put into place, it comes with a limited number of replacement parts. Now, over time, these parts are consumed as the system ages and as different components get worn out. If you run out of replacement parts, you can always order more, right? Well, unfortunately, companies that design replacement parts for their systems may ultimately go out of business while the system is still in use. This means that they won't be around to simply ship you new replacement parts. In order for the owner to continue to use the system they purchased, they must find a way to continue to maintain it. This is often done through redesign or reverse engineering of those spare parts. Now, depending on the application, a particular replacement part must not only handshake with the existing system, but must first pass rigorous testing and certification before it can even be used as a spare part. With reverse engineering, we create a part that matches the exact form, fit, and function of the original PCB. And in doing so, we eliminate the need to design the board from scratch, as well as the need to prototype, revision, and certify the new part. Additionally, without proper documentation, it can be completely impossible to design replacement parts from scratch that will properly interact with the rest of the system. And that's where we come in, hopefully before you run out of spare parts. Now, we typically utilize one of two primary methods of generating a circuit board's design data, destructive or non-destructive. These terms refer to how we use or process the circuit board itself. Ultimately, to be reverse engineered, a board's going to need to be depopulated and so it'll lose its functionality. But with our non-destructive methods, the components can be placed back on the circuit board and it can be returned to use. Our typical destructive method is based on a serial milling and imaging process where the board itself, the copper connections on the board, are imaged on our high-resolution calibrated flatbed scanners. As I mentioned before, this is our preferred method for capturing images for PCBRE. Since it's tried and true, it provides us with extremely high resolution, extremely accurate calibrated images, and gives us the most flexibility as far as what kinds of features we're able to image. If you look down at the bottom of the screen here, you'll actually see some of the layers of a 6-layer circuit board that we had processed with this destructive method. We started by capturing a high-resolution image of the outermost circuit layers, and then we proceed to mill down and capture images of the subsequent circuit or copper layers. From there, we generate our Gerber or vector data. Our non-destructive methods of reverse engineering can be based on X-ray or CT imaging, but we're also able to partially reverse engineer a circuit card by using a flying probe tester. The difference on these two options is that while neither require the circuit board to be destroyed, only X-ray imaging provides us with images that can be used to generate the exact trace and plane layouts of the inner layers. The downside to X-ray imaging is that the process can be far more complex as far as how we capture the images, and is typically more expensive. In addition, the images captured during the CT scanning process often cannot be used with automated data generation functions, and the data for each of the circuit layers may have to be created manually. If an FPT machine is used, we won't have any of the internal circuit layer data, but we will have a netlist that can be used to create schematics. Whether a destructive or non-destructive method is used, we always start by capturing an image of the surface of the PCB on our calibrated system. If there's no circuit board available, if there's no physical board available, we're able to start the process by referencing any called out dimensions on data sheets. And then we resize the resulting Gerber data to match those dimensions. And if X-ray images are used, the images themselves are resized to match a scan of the physical board, so that each and every layer of the circuit board is dimensionally accurate. Now, for our destructive process, we're able to capture feature sizes down to 12 micron with an accuracy of plus or minus 25 micron across 16 inches. That means that if you scanned at a 16-inch ruler on our system, the 0 and 16-inch marks would be within 25 microns of their actual position on the ruler. This also means that positionally, individual features are going to be far more precise. Using this capability, we're able to exactly replicate the form, fit, and function of the original part. Specifically for RF applications, where the shape of the copper determines the functionality or the ability of the board to transmit a signal, this form, fit, and function is extremely important. For a destructive method and for X-ray based non-destructive RE processes, all of the circuit layers are aligned in the software to match feature locations on each layer, allowing us to perfectly recreate the traces and connections on the circuit layers in vector data. Specifically for our X-ray or CT scanning processes, we start with a dimensionally accurate scan of the top or bottom of the PCB, and then align all of the image slices for the inner layers to that calibrated image. Once we have captured all of the images required for the PCB, we start with Gerber generation as a base for all of our other fab data that is created. For our FPT process, we skip the Gerber generation phase altogether and go straight to netlist. Ultimately, the circuit board's pick and place data and netlist can be combined together and used to create a schematic. Again, if the FPT method is used, we won't have the required data to reproduce the board. However, we will have a schematic complete with all of the parts on the surface of the board, as well as their component information. In the event that a programmable integrated circuit chip determines the functionality of a board, we also have the capability to extract the firmware from that chip, so that it can be written to newer devices. Depending on how the IC is set up, we're able to either read back the original programming directly, or we can take an input-output approach to reverse engineering and recreating the programming on the chip. Once we have all of the data for the circuit board generated, we'll convert it into your required formats. If desired, we can provide you with the high-resolution bitmap images that are captured in the process. Although we start our data generation with Gerber RS-274X, we're able to export TXF, ODB++, IPC2581, and additional formats. And typically for netlist, we'll export IPC D356. It's an ASCII or a text-based file. For component pick and place data and bill of materials, we leave those in spreadsheets. And for schematics, we create an interactive PDF as well as Cadence Allegro. We're able to work in OrCAD, DX Designer, and other proprietary formats. Now, lastly on this screen, here's a quick review of all of our inputs and outputs that we use with our service bureau. On the left, you can see that we use our flatbed scanner. We can use images from a scanning electron microscope. We can use images captured with CT or X-ray imaging methods, as well as other sources like films or datasheets. We can even take CAD inputs and use our software to export the schematic, netlist, bill of material, and pick and place data. On the right-hand side, we have all of our outputs grouped into 4 main segments: PCB fab data, netlist, component information, and schematic. If you're interested in contacting us for more information about our reverse engineering services, you can find out more on our website. Go to www.scancad.com or email us at service.bureau@scancad.com. Our phone number is listed on the screen, and I have included a link to our website in the description below. Thank you for taking the time to join us for this video today, and we hope to hear from you.